Hi, good morning everyone, and welcome to this presentation. This presentation is part of a project called the base-registries of Flanders, which in essence are just a collection of event-sourced applications run by the Flemish government. And today we'll have an introductory course on what is an event-sourced application. So with that, let's get going. And my name is David Kums. I'm the architect of this project. The project is located as a part of a government department called the Flanders Information Agency, and it deals with being the authentic authority for several data sources like how municipalities are named, how streets are named, how the road network looks like, which public services the government offers, which organizations are located in the government, and just being like the central place to keep them all organized and have one truth for them that people can come and fetch data from. First, some credits, since event sourcing isn't that new anymore, and there have been a lot of people who came before us who did some magnificent work already. In particular, Martin, which I'm using quite a bit of drawings from, so be sure to check out his article once you have the time. And then there's lots of evangelists and also things related to event sourcing like event storming. And of course, when we talk about event storming, it's not just IT. Basically every other major industry that has gone before us knows something similar. Like if you want to know something about event sourcing, talk to your local accountant. They figured it all out. Doctors in medicine, they keep on appending to your file. They don't throw away data. When you're in legal and you have a contract and you want to change something to a contract, you're not just gonna strike it through and write something else on it. You're gonna work with addendums. So basically all these mature industries, what do they have in common with that? Is that they don't lose information. And that's like the main thought you need to keep in mind of event sourcing, is that we don't lose any information at all. Excuse me. So this presentation is basically an introduction to event sourcing. It's to have an understanding when going forward, building bigger systems, and it's like a level 100 course, you could say. When we create a system, what's our goal most of the time? We have two main goals when we create a system, and that's basically getting information out to a user quickly, which means in the back, reading from your system should be lightning fast. So people don't want to wait if they want to go and find something on your site. If you want to sell them stuff, the information has to be there like instantly. If they're gonna have to wait, you're gonna lose sales. Next to that, more importantly for the business, is when you're writing stuff, people shouldn't be able to buy stuff for free from your site, for example. So basically the business rules have to be respected. So let's look at a classical example of a shopping cart. You have a customer, basic shopping cart with a few columns, a customer ID, a product ID, and how many are ordered. We can say, like in this case, customer 123 ordered one of product ID 888 and one of 999, and all of a sudden he says like, yeah, I changed my mind, I'm gonna order 3 of those 999s. So in a classical system, what would you do? You do an update statement and you put it to 3. That's all fine. We still have a customer's order when he goes out and when he checks out. But I got a question now. What did this user want, but in the end didn't order? So for example, let's say it was a 3, and just before he ordered, he changed it to a 1 or maybe a 0. In the previous example with the update, we're just gonna have that last number in there, but we don't know what he desired, what he put in his bucket, but eventually deleted from it, maybe because he didn't have money at the time, maybe because, I don't know, any reason is possible, but we don't know with that system. Why would we want to know? Because it's shown in shopping that they're more likely to when they come back in the future, it's more likely that they would buy it if you recommend it to them again. So this is a problem. This is a problem we have. So how do we deal with it? What's a way to deal with it? There are other ways as well. You can create audit tables and keep track of everything, of course. But one of the nice things about event sourcing is that you get these things kind of free. So I'm gonna have a look at event sourcing as a solution to this answer. Some other terms you might encounter when looking for information about event sourcing is domain-driven design, CQS and CQRS, event store. They're all kind of related when you go out there and you start looking for it. So event sourcing, the basics is, do you know what this is? It's accounting. Everybody probably has seen some accounting when they went to school. Whatever you need to know about event sourcing, talk to an accountant. They've probably already solved all the business problems that you might encounter. Because accountants use pens and not pencils. They don't erase anything. When things get difficult, they've already invented procedures to go around it, like they have year-end procedures, they close and reopen books, they do correcting actions, like if you buy something and you made a mistake, you're gonna write a credit note and stuff like that. So how would our previous example look when we saw it through the eyes of an accountant? Basically, you would have, like, instead of a table with the final state in it, you'd have a log of actions, like the customer added it to his cart, then he changed the quantity, then he changed it again, and eventually he checked out. But what this gives us is it's basically going to give us a history about something the customer wanted along the way, but then decided to not go for. Having this information will allow us to update our recommendation engine in the future for this particular customer. And what's the nice part about this thing is we haven't lost any information. We've stored all the steps that the customer has taken. So this is one of the big features of event sourcing. Why auditors will love you. You have a complete track of history, kind of for free in a technical way, since it comes out of the box. You don't have to write any audit logs. Basically, your event log is going to be your audit log. Another nice thing is, instead of just updating a column with a new value, like changing that quantity from a 1 to a 3 without knowing why, this time we can actually enrich changes with business concepts. We can make domain business a first-class citizen again of our projects. We have created a bad habit in business people where they start thinking in inserts and tables and other technical solutions, because IT has been working like that for many years, and event sourcing is a way for us to get back to the business logic, to their domain, to their words, to basically what matters to them. They shouldn't be interested in a table. They should be interested in an event like a customer being, the typical example is a customer moving addresses. Then you want to know, why is an address changed? Was it a mistake? Was it a move? Anything that marketing people afterwards could play with to get some great insights. Anything that could help reporting. Basically, they're getting business back to thinking in their specialty. So from a high level, how does it look? Basically, you have on one side, we store all these events. So all the steps that we just listed when updating a card are events, and they're a history of what has happened. This is our one and only truth. On the other side, we have, when we look at each event individually, one after the other, we can create an aggregate state, which is the end result and what the customer usually sees or what the system needs to make calculations. So for example, in the case of our shopping cart, the events are step by step, and the aggregated data would be the table that we've seen in the beginning of the example, which just has like the final totals on it. You could compare like the raw events are your writes to your database, the aggregated data is where your reads are gonna happen. If this seems like CQRS, yes, that's why I've said it fits nicely. You're separating your writes from your reads. If you want to look at it from a UI point of view, your reads are basically your buttons. When somebody clicks your writes are your buttons. When somebody clicks a button to order something, you're gonna write an event. When somebody looks at a screen, you're gonna be reading, you're gonna be looking at the aggregated data. For example, in Twitter, you have a small text box, which is the right side. People write a tweet. On the output, they have the Twitter feed where they can read all the tweets from the people. And so how does that look in the back? The right is basically just an event that says this user on this time has written this message. Imagine if you have millions of those, one after the other in your event store. Then you could aggregate those things into the timeline, particularly for each user. Another example is Facebook. So the right side is the like button, and the output side is whatever we see in our Facebook feeds. So the command, the event that we're gonna store is basically user David Combs has liked some item on a particular time. And again, aggregating all of that, we can enrich that to end up with the stream of a +1 on a post. So the raw events are basically the source of truth. If you lose everything, but you keep your events, you can rebuild your entire system. So simplifies your backup process quite a bit, since you only have to keep 1 or 2 big tables safe, and the rest is just derived data. So that could cut on costs when you need it. And then on the other side, the aggregated data is, like I said, derived data, which is used to give optimized views, optimized states for whatever use case you need. So for example, that could be like an ETL that fills up a data warehouse. That could be like indexing a full text search, an Elasticsearch or something. That could be updating a Redis cache. That could be feeding some process, which in turn feeds other processes. Anything you can think of, you can play from your stream, from your event stream, and you can module and you can manipulate the data in such a way you need it to become efficiently available for the output side for whatever use case you have. For example, so these are just 4 examples, but you could also fill up some OLAP cube and give people an Excel sheet that connects to it, and they can basically play with all the data. And it would take you not that much effort. Just you have your event stream with all your data, and all these questions become use cases, which you can really focus on, saying like, I have these events, how do I get to the most optimal point to solve that problem, and just focus on that and don't even think about all the rest of your system. So why are we doing this? Well, a couple of things. First of all, loose coupling. If you write data to the database in the same schema as you do for reading as you do for writing, you basically have tight coupling, which means it's going to give you a harder time in the future when you want to scale and when you want to refactor, because you're stuck with possibly adding properties to your read model because you need them for writing, or vice versa. So you get a bit of a mix in between there. When you explicitly separate them, you can make the most optimized structure for both sides, and you get a much looser coupling. And then also you get rid of the discussion about, do you normalize so you can get faster writes, or do you denormalize so you can get faster reads? That only exists because people use the same schema. But if you don't use the same schema, the entire discussion goes away, because you can have and fast reads and fast writes. So having best of both worlds, like having your cake and eat it too. So those things, that's about scaling for yeah, basic scaling, but you can push it to the extreme, because it's not just scaling on a technical level, it's also scaling on a human level, because you have your event stream, and every use case basically starts from those events, and people can be handed very specific use cases, which you could express like, given these events, I want to have an email sent out whenever the total amount of money spent is greater than this, and this customer has been with us for a few years, then I want to give him a promotion, something like that. Something very specific, and lots of those stories next to each other scale out nicely because they don't interfere with each other. So basically what this all ends up to is we gain a lot of flexibility, not just as you've seen on the technical side, scalability server-wise, hardware-wise, infrastructure-wise, but also on the people side, when people work next to each other. They can also play around with changing new system, A/B testing, changing parts of the system to work with new data, while other people still have the old one, which when implemented is basically just the same stream being projected in one side the old way, in another side the new way, and then analyzing them. And finally, when something goes wrong, it's much easier to reconstruct what went wrong, because you basically have a list that says, given these events, somebody did the following, and you expect, so basically it's a unit test almost. You expect the following events to happen. You know that something is going to go wrong, otherwise they wouldn't have mentioned it. So now you can say, given these events and the following command, and then you can start debugging and looking at the error more closely. So those are the main reasons we're doing this. The overarching theme is basically, it gives us a lot of flexibility. It allows us to focus our energy on one point in particular, whether it be writing, thinking about the business domain and which events and commands are involved, whether it's the implementation. It's just flexible all around. And with that, I'm open for questions if you have any. So let's take some time to see if somebody has some. Okay, well, thanks for your attention, and just keep in mind to have fun, which is the most important part of these things we're doing. And whenever you need me, come and find me and ask your questions. Thanks. Bye bye.